Lesson 5.6, Proving Triangle Congruence by ASA and AAS. Which brings us to 5 ways to prove triangles congruent. We had SAS, SSS, HL, when today we're getting ASA and AAS. You need to know all 5 of those. So what do you suppose ASA stands for? That's right, it stands for angle, side, angle. Notice there that the side is between the angles. So if 2 angles and the included side of one triangle are congruent to 2 angles and included side of another, then the 2 triangles are congruent. So notice it's angle, side, angle. The side is between the 2 angles. That's the side, the one between the 2 angles there. That's why it's ASA. The other theorem for today is AAS, or angle, angle, side. So if 2 angles and a non-included side of one triangle are congruent to the same stuff in the other, then the triangles are congruent. Notice this time the side is not between the angles. So here the 2 angles, our side is not between it. So the side between is there. The side that's marked is not between the 2 angles. That's why it's angle, angle, and the side is somewhere else. If it was the one between the angles, then it would be ASA. So in this diagram, what postulate or theorem can you use to prove the triangles are congruent? Well, we already have angle S and angle U congruent. We have RS and UV congruent. So I need 3 things. Remember, there's 3 things. We have our choices of, see, what do we have? We had SAS, SSS, HL, and its third thing is a right triangle. And today was ASA and AAS. So notice they're all 3 parts. So what's the third part we can have congruent here? That's right. That one, because vertical angles are congruent. So we look at this and say, I have 2 angles and a side. Is the side between the angles? No, it's not. This would be the side between the angles, but that's not the one that's marked. Therefore, it is angle, angle, side. All right, some more fun with proofs. Okay, first step. That's right. Put down the givens. And make sure they're marked on the picture. So the little line mark here is congruent. The arrow on the line is parallel. We're supposed to prove these 2 triangles are congruent. Well, what could we do? Well, if the lines are parallel, then we'd know that the alternate interior angles are congruent. So for step 2, I could say angle H is congruent to angle F. Oh, but wait. D and G are also alternate interior angles. So I could say they are congruent. And the reason is the alternate interior angles theorem. Remember, I said if you have parallel lines, then the alternate interior angles are congruent. These angles are between the parallel lines, one on each side of the transversal. And now, do we have enough information yet to say the triangles are congruent? Do we have 3 parts? Why, yes, we do have 3 parts congruent. We have an angle, and then a side, and then the angle. So we have 2 angles. Is the side between the angles? Why, yes, it is. So then we can say our triangles are congruent by angle, side, angle. Let's do another proof. All right, we had this one already, but we didn't actually write the proof. So let's go ahead and write the proof. In fact, to be fun, why don't you pause the video and try it yourself. All right, so now that you've tried it, the step 1 is, of course, write the givens. And then step 2. All right, we want something else that's congruent between the 2 triangles. And we know vertical angles are congruent. Why didn't we use that on the last one? Well, we could have. I just chose not to. I didn't need to. All right, so it'd be angle RTS. It's congruent to angle VTU. So RTS, VTU. And those are vertical angles. So our theorem would be vertical angles are congruent, or the vertical angles congruence theorem. And now, do we have 3 things congruent between the 2 triangles? Why, yes, we do. We have an angle, and then another angle, and then a side. Notice this time the side is not between the 2 angles. So angle RST is congruent to triangle VUT by angle, angle, side.